All right, good morning, good afternoon, good evening, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, please subscribe to the channel and leave a like for this lesson. Now, in today's lesson, we are going to look at this tutorial sheet, and basically, we've done most of these questions, but I'm just going to give a recap. So, sit back and enjoy. So, we've been given f of x. We've been given f of x, which is equals to 6x squared minus 2x plus 1. And I'll work out this problem right here. And you're asked to find f of negative 3 plus 2 times f of 5. Okay, so you're asked to find this. So first of all, you can work out f of negative 3. So f of negative 3 will be equals to putting negative 3 here. So f of negative 3, we're putting negative 3 in here where there is x. And we're going to have 6 negative 3 to the power 2 minus 2 times negative 3 plus 1, which will simplify to 9. So this will be negative 3 squared, that is 9. 9 times 6, that is 54. So this will be 54. Negative 2 times negative 3, that will be positive 6 plus 1. Positive 6 plus 1. Okay, so now this will add up to, this will be 61. This will be equals to 61. Then we also need to find f of 5. So basically, our f of 5 will be equal to putting 5 here where there is x, so here and here, so that would be 6, open brackets, 5 to the power 2 minus 2 times 5 plus 1. Okay, so simplifying this, we're going to have 6 times 25 minus 10 plus 1. Okay, so 6 times 25, that is 125. Negative 10 plus 1, that will be negative 9. So this will give us, oh sorry, apologies, here this is 150. So that is 6 times 25, this will give us 150. Then minus 9, that will give us 141. Apologies on that one. So 6 times 25 will give us 150. Then negative 10 plus 1, that will give us negative 9, and this will be 141. So we have our f of 5, which is equals to this, and f of negative 3, is equals to this. So now we can replace in our equation here. So here we are replacing the value of f of negative 3, which is 61, plus 2 times, here we replace the value of f of 5, which is 141. Then we simplify this. So we simplify this further. This will be 61 plus 2 times 141, that is 282. Then adding that will give us 343. And that answers our question. So that is the solution to this question right here. So the answer here is 343. Okay, now let's look at other questions that we have. So I'm going to use the first principle on this equation, then you can try to use the first principle on this, then we'll move on from there. All right, so the next question asks us to find dy dx using the first principle. So I'm going to work out this one, then the rest you can work out by yourselves. All right, so firstly we need to understand what the first principle says. So the first principle basically says dy dx is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Right? So the first thing that we have to do is identify our f of x, okay, which is basically the function we're differentiating. So the y part is the f of x, and it is equals to this. So f of x is equals to 1 over x in this case. All right. So now we know what our f of x is, which is what we're going to put here. Now we need to find f of x plus h, which is what we need here. So this simply entails that wherever there is x, we are putting in x plus h. So wherever there is x, we're putting in x plus h. So this will be equal to 1 over, here where there is x, we're putting x plus h. Now we can substitute in the first principle equation. So dy x will basically be equal to the limit as h approaches 0. Then this part is this part. So this is x plus h. Where there is x, we put x plus h. So this is x plus h. So this will be f of x plus h, which is this part, will be 1 over x plus h minus f of x, which is this part, which is 1 over x, divided by have here. From here, we have to simplify the numerator. So we simply say this is equals to the limit as h approaches 0 of 1 over x plus h minus 1 over x divided by h. So this whole thing is being divided by h. That is the division there. So here we look for the common denominator. This will be limit as h approaches 0 of the common denominator is x plus h, and we get this into there. That is just x, and x times that will be x. This into there, that is x plus h, so minus x plus h, like that. Then we can change division to multiplication by considering the reciprocal, which is 1 over h. So now after doing that, we can further simplify. So this is limit as h approaches 0 of, we distribute, this will be x minus h all over x squared. So we can distribute x squared plus xh, then times 1 over h. And what is interesting here is that the x and the x cancels out, and we can factor out the h on top there, so that we have limit as h approaches 0. So we factor out, well, let's write what is remaining. So that is negative h all over x squared plus xh times 1 over h. So simply this can simplify. So we can say this there 1 and this there, that is negative 1. So what we are going to remain with basically is the limit as h approaches 0 of negative 1 over x squared plus xh. Now after getting rid of this h, you can finally substitute h equals to 0. So this, where there is x, where there is h, you're putting h equals to 0. So that would be negative 1 over x squared plus x times 0. So x times 0 will basically be equal to 0. So this simplifies to negative 1 over x squared as our final answer there. Okay, so that is the first principle. Just maybe a run through. This is the formula for the first principle. So dy dx is equals to this. Sometimes we can write it as f prime of x is equals to whatever is here. So now we identify our f of x, which is the function that we are differentiating. Then now in x here, according to the formula, we should have x plus h. Basically, where there is x in the f of x, we're going to place x plus h, which we did here. Placing x plus h here, we're going to have x plus h here. Then we replace back f of x plus h, which is this, which is required here. We put it here. And negative 1 over x, we put it here over h. Okay, then from here we started simplifying. So we said over h, we found the common denominator here, which is, or before that, we said this is the same thing as division out here of h. Then we started looking for the common denominator and simplified everything. Okay, so that is how you were supposed to work out this problem. All right, so we go to question 3. If f of x equals to 3x 2x squared, find f prime of x from the first principle. So again, here we're using the first principle. So basically, we have f of x, which is this, and according to the first principle, dy dx is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So now we need to find f of x plus h from here. So basically, we need to find f of x plus h. Where there is x, here we're going to replace x plus h, and here this will be equal to 3 open brackets x plus h minus 2x plus h squared, like that. So now here we can replace these variables where we need them. So f of h, which is equals to this, can be replaced here, and f of x, which is this, can be replaced here. So we're going to have y dx being equal to the limit as h approaches 0. F of x we have, which is 3. We can expand this part, so this will be 3 times that will be 3x plus 3h. Then this one we have negative 2 times, we can expand this part, which will be x squared plus 2xh plus h squared. So that is done with the first part. Then for the second part, we say minus, we put it in parentheses, 3x 2x squared. This is all over h. So now we can further simplify. So that this is equal to, so this is equal to, so we can say this is 3x plus 3h. Distribute this times this, that will be negative 2x squared. This times that, that will be negative 4xh. This times that, that will be negative 2h squared. And we distribute this times that, that will be negative 3x plus 2x squared all over h. Now here, this is where we have a limit here. Limit, so limit as x approaches 0. So the limit will only be go to the end. So here we see that there are like terms. So there are terms that are like, and they have different signs. So most likely they'll cancel out. So we see this and this will cancel out. We have this and this cancel out. So those are the the variables that will cancel out. So we have limit as h approaches 0. Then this be 3h. This will be negative 4xh. minus 2h squared all over h. So we can factor out h on the numerator. So we're going to have limit as h approaches 0. Factoring out h, we're going to have 3 minus 4x minus 2h all over h. So we see that this h and that h cancel out, and what we remain with is limit as h approaches 0, 3 minus 4x minus 2h. Now, after simplifying, we can replace now h, where there is h, we can put 0. So this will be equal to 3 minus 4x 2 times 0. Okay, so that will give us a 0. And the derivative is basically going to be, okay, so f prime of x is basically going to be equal to 3 minus 4x, because 2 times 0 will be 0. So 4 minus 2x. Now the question further asks, so the equation further asks to find f prime 4. Okay, so f prime of 4, basically we have f prime of x, do have f prime of x, which is equal to minus 4x, and f prime of 4 basically we will be replacing in f prime of 4 being equal to, where there is x, we put 4. So this will be 3 minus 4 times 4, which will be equal to, this will be 16 minus 3, that is 10. Okay, then f prime of 1, so f prime of negative 1, again where there is x, we're here, so this 3 minus 4 times 1, which simplifies to 3 plus 4 is equal to 7. Okay, so done with that question. So that's question number 4.